In probability, some events may have no outcomes in common. These events are called mutually exclusive. For example, when rolling a six-sided die, the events rolling a prime number and rolling a 1 are mutually exclusive. It is impossible to roll a prime number and a 1 in the same roll because 1 is not a prime number. These events can be represented using a Venn diagram with two circles that do not overlap. For the event of rolling a 1, there is only one possible outcome. For the event rolling a prime number, there are three possible outcomes: 2, 3, and 5. The remaining two outcomes, 4 and 6, do not belong in either event. There are no outcomes common between the two events, which is why they can be drawn with no overlap. Let's say that events A and B are mutually exclusive and consider the probability that event A or event B occurs. This is the probability of A or B, or the probability of the union of the events A and B. In general, that probability is the sum of the probability that A occurs plus the probability that B occurs minus the probability that both A and B occur. This last term is the probability of the intersection of the two events A and B. However, if A and B are mutually exclusive, then there is no outcome in that intersection. Therefore, the last term must be 0. This leads to a simpler formula for the probability of the union of two mutually exclusive events. The probability of either event occurring is equal to just the sum of the individual probabilities. Let's return to our die example. What is the probability of either rolling a prime number or a 1 on a die? In this example, let A be the event of rolling a prime number, and let B be the event of rolling a 1. There are three prime numbers on a six-sided die: 2, 3, and 5. So, the probability of rolling a prime number is 3 over 6, or 1 over 2. The probability of rolling a 1 is 1 over 6. The probability of either of these events occurring is equal to the sum of the probabilities, which is 4 over 6, reduced to 2 over 3.